Welcome back to my channel. Today in this tutorial I am going to explain another real-world locking example where we can book the ticket. Whenever we are going to book the ticket, there some kind of locking mechanism is required to avoid whenever the simultaneously booking a ticket. So maybe there is a, if we are not going to use the locking in behind, then it's causing overlapping of the tickets. So here we are going to demonstrate how to use locking mechanism to handle concurrency in scenarios where multiple threads or multiple customers attempt to book ticket simultaneously. So here if we describe the problems in online ticket booking system, multiple user, or in a programming language you can say multiple threads try to book tickets at the same time. So tickets are limited, like maybe 50, 60 in a bus, or maybe in a 10 more than that. So proper synchronization is required to prevent overselling or incorrect booking. Let's say we are going to write some program to demonstrate that if we are not going to use the locking system, how it will be look like and how the book ticket are happening. So without locks, race condition may occur where two users book the same ticket simultaneously. Let's say there is a one ticket is left and two users trying to book the same ticket. So if we are not using the locking system, then two users maybe successfully book the same ticket, right? So that can happen. So that kind of things we are going to demonstrate over here. So now let's think about, we are going to create one class over here. We are going to create that class. Let's say ticket counter class we are going to create. So here we are going to implement without locking. Now after that we are going to create another, we are going to apply the locking. So here first of all we need to defining the available tickets fields over here. In a constructor actually we are going to set that particular fields, right? This is a parameterized constructor. If you are not aware of it, if you see for the constructor class name and the method name should be similar of this, it doesn't have any return type. So that's why it's a constructor, and here we are initializing this particular variable. Now inside of we are going to create one method booked ticket where we are going to write the logic for booked the ticket. So here if you see, here basically we are taking two parameters. One is the passenger name and another one is the ticket to books. So obviously this is the number of count, that how many tickets they want to book. So obviously if it is a less than or equal to available tickets, let's say there is a 10 number of available tickets, then this will be less than or equal to 10. If not, then it will say that failed to book, not enough tickets available, else it will print the details like passenger name is booking the ticket to tickets, and then it's actually decreasing the number of ticket, right? So this is the very simple and core logic of booking system, correct? In next, what else we are going to do? We are going to test this method and the application. So for that we are going to create another method where we are going to write the main method. So here we are going to create another class, let's say ticket booking test. It contains the public static void main method. So we need to create this particular class. Then we are going to create one object for which class? For this class ticket counter, right? And this is the default or parameterized constructor. So we need to pass this available ticket while creating the instance for this particular class. So here if you see the ticket counter, this is the class, and we are passing the number of seats are available to 5. Okay. Now basically we are going to create one thread. Let's say thread t1 equals to new thread. The first parameter, this is the runnable method we need to pass. So here, using this object, we are calling this book ticket. The first parameter is the customer name, and this is the how many seat they want to book. Okay, in similar fashion we are going to create another two thread over here, like thread t2, where this is the first, this is the name and how many seats they want to book, and similar for this Charlie, right? So just repeating one more times like this. Currently here we are not implementing any locking mechanism, right? So it is implemented without locking, and here the available seat is the 5, but here thread T1 need the 3 seats, the thread 2 is need again 3 seats, and the T3 is need 2 available seat. So we are having the total 5, but here the requested seat is the 6 plus 2 is 8. So obviously some seats we are not able to book, right? But here we have not implemented any locking mechanism. So let's run this application and see what is happening, because threads are running simultaneously, right, without depending on each other. So now we have started this application. Okay, run as Java application. Okay, so it's not printed anything. Okay, basically we have not started those threads. So for starting this thread, we need to write some thread dot start method, t1 dot start, t2 dot start, and the t3 dot start, right? Now it will basically start the thread. So now if you see, Bob is booking 3 tickets, Charlie is booking 2 tickets, so remaining tickets are 0. And now then after that, means in the meantime Bob also successfully these 2 ticket, and then after that somehow this is also, this Elias is also booking the 3 tickets, so remaining tickets will be -3, right? So that means it's actually means not actually is working properly, right? Because -3 means it's a overflow conditions. So as we have not implemented the locking mechanism, and this multiple thread they can access those things at any time, so we don't have any mechanism to stop there without locking. So that's why this is actually we are getting overflow kind of things over here. To avoid this, we need to apply some kind of locking mechanism. So first of all, we can use the synchronize block. So add a synchronize block to ensure only one thread can execute the booking logic at a time, right? So here what we can do, here we can use this synchronize block, so that this particular block will be synchronized, and at a time only single thread can access this. It's ensure the thread safety, prevent the race condition by serializing access to the book ticket method. Now if we start this application and see that how it is behaving. Now if you see, it's actually trying to book the 3 tickets T1, then remaining tickets actually 2, because we are having the available seat or available ticket is the 5. Charlie is trying to book the 2 tickets, so now the remaining tickets is become 0. After that, when this Bob actually trying to book the ticket, then Bob here if you see the message, Bob failed to book because not enough tickets available. So now actually it's behaving properly. So here we are not getting any kind of overflow type things because we have used the synchronize block. Now this kind of things again we can achieve in different way using re-entrant lock for advanced control. Use re-entrant lock to have finer control over locking and the unlocking, enabling features like timeout or interruptible locks. How we are going to doing that? For that, here basically we need to use this. Here we can create one object, this re-entrant lock. This reentrant lock actually is coming from this concurrent package, concurrent.locks.reentrant locks. Okay, this lock object. Now here basically we can don't need to use the synchronized over here. Instead of that, we can use this lock.lock. Okay, here basically it's acquiring the lock, and within the finally we can unlock the lock. Okay, so this is the lock actually, and then it's actually always release the lock. So this lock.unlock. So it's actually provides additional flexibility over synchronize, such as checking lock status or acquiring the lock conditionally. So this is also doing the similar kind of thing as synchronized block do, but it is a more advanced things. Here we can get more feature, more functionalities to do the locking system. Now if we start this application, so it will also behave properly. Like if you see Bob is successfully booked the ticket, then this is actually failed because not enough ticket available, because Charlie meantime actually doing the thing, so that's why. But we are not getting the enough tickets. Like at least we are getting the some kind of validation that they are not able to book the ticket due to some reason, due to insufficient seat. So previously without locking we are not able to do this kind of activity. So this is the benefit, or this is the thing that how we are going to use this locking mechanism in our program in a real world application. Whenever like we are going to purchasing some tickets, booking a movie ticket, booking bus tickets, rail tickets, whenever this kind of things, because multiple threads can access the same seat in a same time, that is possible. So we need to implement this kind of logic to prevent the overflow conditions, right? So this is the thing overall. If you guys have anything, please do let me know in the comment section. Don't forget to subscribe my channel. Please press the bell icon for further notification. Thanks for your time. See you in my next videos. Bye bye.